Learning outcome 2, circulatory system. Circulatory or cardiovascular system is made up of 4 parts: the heart, the circulatory system, blood and lymphatic system. The heart itself is a 4-chambered muscular organ. Its function is that of pumping blood around the body. We have 3 layers, and working outwards to inwards, we have the pericardium, the myocardium, the endocardium. Please note there is a related task in your associated handout to complete. Heart chambers and valves. The heart is divided into left and right sides. The aspect that creates this division is termed the intraventricular septum. Each side of the heart has 2 chambers. They are termed the atrium and ventricle. Thus within the heart we have 2 atriums and 2 ventricles. Please note that the wall of the left ventricle is thicker than that of the right ventricle, and that is normal. The heart valves. The opening between the atrium and ventricle on each side of the heart is as such guarded by a valve, and this valve is termed the atrioventricular valve. The right valve has 3 flaps or cusps, and we term this valve the tricuspid valve. The left valve has only 2 cusps, and we term this the bicuspid valve or mitral valve. Please see the labelled image of the heart structure, showing the right and left sides and all of the aspects that make it up. Please also note the different colour depicting whether the blood and associated aspects of it are deoxygenated or oxygenated, depending on the journey that valve, vein, vessel, etc. is going to go on. What is the function of the valves? The purpose of the valves is to prevent any backflow of blood, i.e. blood travelling in the wrong direction around the heart. This is required when blood is being forced from the atrium onwards into the ventricle. Each valve has attachments made up of fibrous strands known as the cordae tendineae, and the purpose of the strands are to prevent the valves from everting, turning inside out, when the heart contracts. From each ventricle exit onwards into the major blood vessels, we have valves termed semilunar valves. We have the pulmonic valve and the aortic valve. The purpose of the valves is again to prevent blood flowing back into the ventricles, however, at the time of the heart relaxing. Please also complete task H within the associated handout. How does blood flow through the heart? Blood will flow through the heart due to contraction and relaxation taking place alternately. The order in which it does so is as follows. Blood enters the right atrium, returning from the major body veins, caudal and cranial vena cava. The right atrium then contracts and will subsequently force blood into the right ventricle. The atrium itself relaxes and the ventricle contracts. This forces blood out of the pulmonary artery and into the pulmonary circulation associated with the lungs. And at this point we have the closing of the tricuspid valve in order to prevent any blood returning into the right atrium. Blood returns to the heart from the lungs and enters the left atrium via the pulmonary vein. The left atrium contracts and now forces blood into the left ventricle. Now the atrium relaxes and the left ventricle contracts. This forces blood out of the dorsal aorta and sends the blood around the systemic circulation of the body. The bicuspid valve closes, preventing blood returning into the left atrium. Please watch the following video. Circulatory system. It's a network of blood vessels which are required to transport blood around the body. We have three types: arteries, capillaries and veins. Complete task I in your handout. We can further divide into two aspects or systems. We have the systemic circulation. The vessels that supply most of the body are made up by the venous and arterial network. And we also have an aspect to in the hepatic portal system. This is responsible for draining the small intestine. Products that are produced through the digestive system are taken onwards to the liver. Here they are metabolised and thus utilised and ultimately converted into aspects that the body requires. Waste products are removed via the hepatic vein. Pulmonary circulation, the vessels that carry blood between the heart and the lungs. Please note both systems are physically connected, working as a series of continuous vessels that blood moves through. What are the functions of blood? Carries oxygen from the lungs to the cells of the body. Collects carbon dioxide from the cells and takes it back to the lungs. Carries nutrients around the body. It carries hormones produced by the glands to the endocrine system and takes them onwards to the target organ. It collects waste products produced by the cells and takes them onwards to the liver and kidneys for them to be excreted. It has an important role to play in relation to controlling body temperature. It maintains the balance of bodily fluids. It plays an important role in relation to keeping the pH balance in relation to cells and tissues. It's responsible for the defence mechanism of the body, or one of the means of defence, and it prevents hemorrhage using the clotting mechanism. So many functions that are all very important. The lymphatic system is made up of a network of vessels and lymph nodes responsible for collecting and also filtering lymph. Lymph is what we term a tissue fluid. It has a very similar composition to plasma, however it contains more lymphocytes and less protein in its content. Once the lymph has been filtered, it can be returned to the circulation via the heart. Its functions are: return tissue fluid to the circulation, filter potentially harmful or damaging material from the lymph. It produces antibodies and also lymphocytes as part of the body's defence mechanism, and it transports fat from the intestine and moves it to storage sites around the body. Lymphatic circulation. In relation to the body's tissues and organs, lymph will leak out of the networks of blood capillaries and it bathes the cells. It diffuses across into thin-walled lymphatic capillaries, which then go onwards and drain into larger vessels. These larger vessels in some cases contain valves to prevent any pooling or accumulation of fluid occurring in relation to the animal's legs or feet. The large vessels go on to empty into the right atrium of the heart. This is the way in which the tissue fluid rejoins the blood circulation. And there are three large lymphatic vessels for you to be aware of: the thoracic duct, the right lymphatic duct, and the tracheal ducts. Please complete the related task within the associated handout. Lymphatic system continued. In the lining of the small intestine are finger-like projections termed villi. Within the villi are specialised lymphatic capillaries known as lacteals. In relation to the digestive processes, digestive fat can be found within a milky fluid that we call chyle. This diffuses into the lacteals and passes onwards to the cisterna chyli, found at the distal end of the thoracic duct, in the cranial aspect of the abdomen. The chyle is then added to the rest of the lymph and is carried by the thoracic duct on its route to the heart. Please complete task L within your associated task in the associated handout. Lymphoid tissue. In other areas of the body, there are areas of lymphoid tissue. These are very important in relation to the body's defence mechanism. They are the tonsils, found in the walls of the pharynx, responsible for monitoring aspects entering both the digestive and lymphoid tissue. In other areas of the body, there are areas of lymphoid tissue. These are very important in relation to the body's defence mechanism. They are the tonsils, found in the important site for forming lymphocytes. Monitoring aspects. The gland is found in digestive lymphoid tissue. In other areas of the body, there are areas of smaller masses of such tissue. These are very important in relation to the body's defence mechanism. They are the tonsils. It is attached to an aspect as an important site for forming lymphocytes. Monitoring aspect. The gland is found digestive in relation to developing a lymphocyte. The liver is named or spread blood smaller masses of such tissue. The foreign central such as the larger small intestine. The spleen. It is attached. It is important you have an understanding of the composition of blood. It is a range of different cells that are suspended in a liquid material matrix that we term plasma. Plasma makes up around 55 to 70% of blood, and it is this part that will remain when a blood sample is centrifuged to allow testing. It contains all the vital aspects that are transported in blood. This includes hormones, waste products, proteins, and also mineral salts. Please complete Task J in the associated handout.